Welcome back, Physics fans, and we're on example number 3 from Concurrent Equilibrium. This is example number 3. There's a rope here, and another rope here, and another rope here, and they're attached to this unknown mass. And this one up at 60 degrees to the ceiling is tension 2, and we're told that it's 300 newtons. Tension 3, we don't know what the tension is, and it meets the angle ceiling at 40 degrees. And what is T1? We don't know that, and we don't need to find the mass. Okay, so this is going to be a good question. And okay, here we go. Let's draw T3. And it meets an angle at 40 degrees, so that means to the horizontal it's measured at 40 degrees. So this is 40 degrees, and we have a vertical component of it and a horizontal component of it. This will be T3 times the cosine of 40, and this is going to be T3 times the sine of 40. And that's the vertical component of that. Let's just move that one over. It looks like it's getting a little close to our diagram here. And then let's draw the other one. This T2 a little bit higher up. That has an angle of 60, so to the horizontal it also has an angle of 60. And the components of that, this will be T2 times the sine of 60, and this will be T2 times this will be the sine of 60, and this one will be the cosine. Okay, and let's just put that in as cosine of 60. Okay, now we know from the rules of static equilibrium that all the forces in the x direction, the sum of the forces in the x direction have to equal 0. That means the forces left has to equal the forces right. And the forces left is this T3 cosine 40. And the forces right is T2 cosine 60. We know what T2 is. They gave it to us. T2 is 300. So T3 is going to equal 300 cosine 60 divided by cosine 40. And so T3 is 300 times cosine 60 divided by cosine 40. And I'll have to go back there because I have to put a closed bracket on that. Divided by cosine 40, close bracket. And that'll give me that T3 is 195.8 newtons. And then we can do, that's the sum of the forces in the x direction. That gave us an answer. Now we'll do the sum of the forces in the y have to equal 0, the up and downs. So the forces down has to equal the forces up. Just going to change color here, change to blue. So the forces down is just this weight, which is mg. And the forces up are going to be this one, which is T3 sine 40 plus T2 sine 60. We know all these numbers except for m. So m is going to equal 9.8. No, m times 9.8 is going to equal T3, which is 195.8. Multiply that by sine 40 plus T2, which is 300 sine 60. Okay, and let's do that. We'll do the 195 times the sine of 40, and that's going to be 125.86, and that's going to be Newton meters, and 300 sine 60, 300 sine 60 is 259.81. We're going to add those together, and we get the total. I guess it's not Newton meters, it's newtons, my bad. Is going to be 385.67 newtons, and that'll be the force up. So that's how much the weight is. And so m is going to equal, divide that, that's going to be m times 9.8. So let's divide that by 9.8, and we get m. Then we get 39.35 kg. Okay, the direct way of doing this will be just slightly different. Let's see how to do it. Let's copy that picture. See it again. And this time we draw a free body diagram of it and then rip it apart. So there's a force this way of T2. We have this way of T3. And we have this way of mg. Okay, it's actually force of gravity, but I'm going to start cheating and not actually call this my free body diagram, because this is 60 and this is 40. That makes this, let's just now drag these apart and try to figure it out. Let's go back into the drawing mode. Let's draw the mg first. I don't know. Yeah, let's draw the mg first. And then T3, and that's 40 degrees. So that makes that 50 degrees because it has to be a right angle. And then T2, and we're told that this is 60 degrees because that's what T2 meets the, so that means that is 30 degrees. If that's 30 and that's 50, then this has to be 100 degrees. Sum of the angles of a triangle equal 180. And this is mg. We don't know what that is, but this one, T2, is 300. And that's T2. And this will be T3. Okay, so we have a nice triangle to do sine law and cosine law with. So we want to find out what mg is. That's across from the 100. So mg over the sine of 100 is going to equal, okay, and let's do the known one of 300 here. There's 300 across from the 50. So we'll do 300 over the sine of 50. So let's solve for mg. mg is going to equal 300 times the sine of 100 over the sine of 50. Mr. Calculator, 300 times the sine of 100 divided by the sine of 50. This will give you what mg is, and then divided by 9.8, and we get the exact same number we had up top, that m is going to equal 39.35 kilograms. Two different ways of doing it. One is by components. This was components. And then this one down here is by the direct method, which requires perhaps the use of sine law or cosine law, because we're going to get a triangle and it might not be a 90-degree angle triangle. Thank you very much. Smash that like button, and here's the jingle. Don't forget to leave a beautiful comment down below, or just say hi.